Today we will be finishing our factoring unit, and we're specifically going to be working on factoring quadratics. I'll also have a GCF. So when factoring quadratics, sometimes it's easier to factor out a GCF. So we always want to check if there is a GCF. So again, we always check for a GCF. So when factoring quadratics, always check for a GCF because it makes your factoring later on a lot easier if there is a GCF, of course. Sometimes you'll be able to factor out the coefficient, which is a number in front of the x squared. And the nice thing about factoring out the coefficient in front of the x squared, which is a number next to the x squared term or the squared term, we can now use the shortcut instead of grouping. So what I mean by that, let's say we have something like 7x squared plus, let's say, 14x plus 70. If we take out a 7 from here, factor out the 7, we end up with a quadratic that we can probably use the shortcut in this case. So I would not have to use grouping. This is probably not the perfect example, but the general idea is that this term ends up being by itself, which means we have that invisible 1, which now means I can use the shortcut. All right, let's go ahead and move on. Let's get into our examples. All of these will actually have a GCF. This is the one we just saw a minute ago, number 1. And when we didn't do the GCF on this one, we got this really big number, like 1,024, I believe it was. So it's better not to even try doing it that way, although technically you could, but you're still going to have to take out the GCF at the end. So we're going to be doing multiple factors here. So we always start off by asking ourselves what number factors in to 8, 48, and 28. So in this case, we will divide everything by 8 in this case. All right, so I'm going to see that this is 8 times 6, and this is 8 times, let me think about it, 16. This is just 8v squared. I won't need to take out any variables since the last term does not have a variable on it. So we're just going to factor out the 8. We have v squared plus 6v minus 16. And notice that this trinomial that ends up inside my quadratic is actually way easier to factor than trying to factor it with that large number from before. So I'm going to go ahead and draw my own x. Again, they won't be drawn for you, so you'll have to do it on your own. So I'm going to put my x factor here. First and last number multiply, and that gives me a 16 negative. So I'm going to put negative 16 here. My middle term is a 6. So I'm thinking of two numbers that multiply to 16 and subtract to 6. So I'm thinking 8 times 2 is 16. 8 minus 2 is 6. I want the 2 to be the negative. So I can now take these two numbers and use the shortcut for factoring since I have an invisible 1 right here. So I'm just going to go ahead and write that out. V plus 8 and v minus 2. And one major thing is don't forget the GCF you originally factored out. So this is my final answer. Again, way easier than trying to multiply 8 times 128 and getting that ginormous number and then trying to factor that out. It's just not even worth it. So this is a lot faster. Always check for that GCF first. Let's go ahead and move on to the next problem. All right, number 2. I think I skipped it. There's number 2. All right, so again, we have pretty big numbers again. Always check what can we divide these by. So these are all multiples of 6. This is 6 times 8. Let me go back to the problem. 6 times 8. And the other one is 6 times, I believe, 15. That's it. And this is just 6x squared here. So I'm going to factor out that 6 in all of them. X squared plus, not plus, minus 8x plus 15. Again, this allows me to use my shortcut again, so that's a great thing because I wouldn't have been able to use the shortcut had I done 6 times 90 from the start. So I'm going to go ahead and draw my x. First term times last term. It's 15 times invisible 1. It's 15. Negative 8. At this point, it's just a repeat of what we've been doing. Numbers that multiply to 15, 3 times 5. They add up to positive 8. If I want them to add up to negative 8, both need to be negative in order for them to add and be positive 15 on the top. Use my shortcut, after the x factor. And don't forget to bring down your GCF in 6. All right, let's go ahead and move on to the next one. So in this case, my GCF, these are all multiples of 5. So I'm going to go 5 times 5. In this case, they all have the variable k. So I'm going to write out the k's and factor out a 5 and a k. So in each of these, I'll be factoring a 5 and a k, a 5 and a k, and so on. So my GCF will be 5k on the outside. I'm left with 5k squared plus 16k plus 12. So I have my quadratic now left over. I'm going to go ahead and do my x factor. So again, I multiply the first term and the last term, 5 times 12. That's going to give me 60. 16 goes at the bottom. Two numbers I multiply to 60 and add to 16. It's 10 times 6. Now here, I cannot use my shortcut because of this 5. So here I am forced to and required to use grouping. So I'm going to go ahead and do that. So I'm going to split this middle term. I have 5k squared. The 16 gets split to 10 and 6. 10k plus 6k, and drop my 12. All right, so from here I'm going to go ahead and group. So the numbers on the left are multiples of 5, so I'm going to factor out a 5 because this is a 5 times 2 and this is a 5 times 1. And we also have k's in common, so we're going to factor out a 5 and a k. So if I factor out the 5 and the k, I'm left with a k plus, factor out 5 and k, 2. On the right side, these are both multiples of 6. So I'm going to factor out a 6, and I'm left with k plus 2. Again, my two factors match my binomials. That's my new GCF, k plus 2. So I write down k plus 2, and my leftovers are 5k plus 6. And one thing we don't want to forget about is our GCF. So make sure you always bring that down. So I get my final answer, which is 5k times the quantity k plus 2 times the quantity 5k plus 6. So again, this is probably the hardest type of problem you will do, where you have to do a GCF at the beginning with a letter, not just a number, then do the x factor, but then you're going to have to use grouping. So this is probably like the most difficult type of problem you will get. All right, let's go ahead and try those next two problems out. Try them on your own, then come back to the video and see if you got these right. All right, now that you've actually tried 4 and 5, let's go ahead and check your answers real quick. You should have factored out a 2 instead of trying to go straight to the x factor and grouping. So when you factored out your 2, you should have gotten 2n squared plus 9n plus 18 because you divided by 2. Or you broke it down with 2's. Then you did your x factor here, 18 and 9. You should have gotten 6 and 3. That lets you use a shortcut, so n plus 6, n plus 3. Final answer. Right side, you should have factored out a 3. When you divide these by 3, you should have gotten, let's see, let me just change this color here real quick. All right, when you divide by 3, you should have a GCF of 3, and you're left over with n squared minus 2n minus 15. Where's my 15? There it is. All right, and you can use your shortcut again. So what multiplies to negative 15 and negative 2? You should have done 5 times 3, where the 5 is negative. Use your shortcut. Don't forget the 3 in the front. And minus 5 and n plus 3. So again, only key thing we're adding here is this whole GCF piece at the beginning. Again, always check for that. One thing is it won't always work, but if you have a GCF, use it. There will be problems where you can't have a GCF or there won't be a GCF. So just always double check for a GCF. Now, we're going to go ahead and do some whiteboard problems when you get called up. But last thing is just get started on the how do I factor at the bottom. You're just going to be matching real quick and then just doing practice problems. Good luck.